Space, the vast, silent ocean in which we drift. For millennia, humanity has looked to the stars and asked, where did we come from? Today, we turn that question on its head and ask the ultimate cosmic question: how will the universe end? We're not talking science fiction, we're talking science. Modern cosmology, powered by telescopes, particle accelerators, and mind-bending mathematics, has produced 4 leading scientifically validated scenarios for the final fate of everything that exists. None of these endings will happen in our lifetime, or even in the lifetime of our species. But understanding them reveals the profound laws that govern reality itself. Today, we explore 4 scientific scenarios for the end of the universe: the Big Freeze, heat, death; the Big Rip, the Big Crunch, vacuum decay. Let's begin our journey to the ultimate edge of time. Our first scenario is the most widely accepted among cosmologists today: the Big Freeze, also known as the heat death of the universe. It's built on one of the most fundamental laws of physics, the second law of thermodynamics. This law states that entropy, a measure of disorder, always increases over time in a closed system. Eventually, energy spreads out until it reaches perfect, uniform equilibrium. At that point, no more work can be done. Nothing changes. The system is dead. Now, apply this to the entire universe. Observations show the universe is expanding. In 1998, astronomers made a shocking discovery. That expansion is accelerating. The culprit? A mysterious force called dark energy. Dark energy makes up roughly 68% of the universe's total energy content, and we still don't know what it is. If dark energy remains constant, as current data suggests, the expansion will continue forever. But it will get slower and slower until galaxies drift farther and farther apart. Let's walk through the timeline. 100 billion years from now, star formation ceases. All the gas needed to birth new stars has been used up or blown away. Existing stars burn out one by one. 1 trillion years. The last red dwarf stars, the longest-lived stars, finally flicker out. The universe is plunged into perpetual darkness. 39 years. Even the most massive black holes evaporate. Stephen Hawking theorized that black holes emit faint radiation, Hawking radiation. Over unimaginable time, they lose mass particle by particle until, poof, they vanish in a final burst of energy. Beyond 100 years, only elementary particles, electrons, positrons, photons, remain, spread across an ever-expanding, cold, dark void. The universe has reached maximum entropy. No stars, no planets, no life, just a thin soup of particles at near absolute zero. This is the heat death, the Big Freeze. The universe doesn't end with a bang. It ends with a whisper, eternal, cold silence. If you're finding this journey through cosmic fate as fascinating as we are, hit the like button right now. It tells YouTube that you want more deep dive science content, and we'll keep bringing it to you. Now, let's consider a far more violent end, the Big Rip. What if dark energy isn't constant? What if, instead, it gets stronger over time? This idea, called phantom dark energy, was proposed in 2003. If the equation of state of dark energy is less than on a value we can measure, its repulsive force will accelerate exponentially. Imagine this: as dark energy intensifies, The expansion rate of the universe doesn't just increase, it goes parabolic. Timeline of the Big Rip. 60 million years before the rip, galaxy clusters are torn apart. Galaxies drift away from each other faster than the speed of light. From our perspective, the night sky grows emptier. 3 months before the rip, the Milky Way itself unravels. Stars are ripped from their orbits. 1 hour before the rip, planetary systems disintegrate. Planets are flung into space. 1 minute before the rip, planets are torn apart. Mountains crumble. Oceans vaporize. 10 to the power of -19 seconds before the rip. Atoms themselves are ripped apart. Electrons are torn from nuclei. At the moment of the rip, space-time itself shreds. The fabric of reality tears apart down to the Planck length. Time stops. Everything ceases to exist. The Big Rip isn't just the end of stars, it's the end of space and time. Current data from the Planck satellite and supernova surveys shows dark energy is very close to a constant value equation of state is approximately equal to 1. So, the Big Rip is unlikely, but not impossible. If future measurements shift, this nightmare could become our destiny. Scenario 3 takes us back to an older idea, the Big Crunch. In the early 20th century, many physicists believed the universe must eventually collapse under its own gravity, the opposite of the Big Bang. This would happen if the density of matter in the universe was high enough to overcome expansion. How would it unfold? As expansion slows, gravity gradually wins. Galaxies stop moving apart and begin to rush back together. Over billions of years, they collide, merge, and heat up. Temperatures soar. Stars are compressed, then crushed. Black holes merge into supermassive singularities. The final moments are a cosmic implosion. All matter, energy, space, and time collapse into an infinitely dense point, a singularity just like the one that birthed the universe in the Big Bang. Some theories suggest this could trigger another Big Bang, creating a new universe, an oscillating universe. But there's a problem: entropy. Each cycle would have higher entropy than the last. Eventually, entropy would prevent a new expansion. The cycle would stop, ending in heat death anyway. Why is this scenario now unlikely? Because of dark energy. Its repulsive force is pushing the universe apart faster than gravity can pull it back. Current measurements indicate we live in a flat or open universe, meaning expansion will never stop. The Big Crunch remains a beautiful, poetic idea. But today, science says it's almost certainly not our fate. Love exploring the cosmos? Follow us on Instagram and Twitter at Cosmos Explained. We post daily space facts, breaking news, and stunning astrophotography. Link in the video description. Our final scenario isn't about gravity or expansion. It's about the fundamental fabric of reality. Welcome to vacuum decay. According to quantum field theory, the universe exists in a vacuum state, the lowest possible energy state. But our vacuum might be unstable. It could be a false vacuum, sitting precariously atop a metaphorical hill. A tiny nudge could send it tumbling into the true, lower energy, true vacuum. How could that happen? Through a random quantum fluctuation, a spontaneous bubble of true vacuum appearing anywhere in space. Once formed, that bubble expands at the speed of light. Everything it touches, matter, energy, Space-time itself is instantly transformed into the new vacuum state. For anything outside the bubble, the change is instantaneous and undetectable until the bubble reaches you. There would be no warning, no escape. One moment the universe exists, the next it's fundamentally different. All physics, as we know it, ceases. Stars, planets, galaxies gone in a flash. The good news, if our vacuum were unstable, such a bubble would likely have already formed. The universe is 13.8 billion years old. Current measurements suggest our vacuum is metastable, stable enough that decay is incredibly unlikely, but not impossible. Vacuum decay is the ultimate cosmic butterfly effect. A single quantum blip could erase everything. So, which scenario will play out? If dark energy stays constant, big freeze. If dark energy grows, big rip. If dark energy weakens enough, big crunch. If a quantum fluctuation occurs, vacuum decay. Right now, the big freeze is the favorite, yet cosmology is ever evolving. Tomorrow's telescope could change everything. One truth remains. We are incredibly lucky. Against astronomical odds, conditions allowed life to arise right here, right now. Understanding these endings isn't about fear, it's about gratitude. It reminds us to cherish our fleeting moment in the cosmic story. The universe may end in cold silence, a violent tear, a crushing collapse, or a quantum blink, but our story is happening now, and that makes it extraordinary. Thank you for journeying with us to the end of time. Before you go, do 3 things. Smash that share button. Spread cosmic curiosity with friends. Subscribe to the channel. We release new deep science videos every week. Head to the link in the description for our free downloadable guide, The Universe's Fate, a scientist's cheat sheet. It summarizes all 4 scenarios, timelines, and the latest data. Keep looking up. The universe is waiting.